Hey, welcome to my first ever video. I'm doing the Fast AI course, and I assume if you're looking at this video, you probably are too. I wanted to share what I learned. Obviously, as Jeremy talks about, actually teaching is the best way to learn. And there's actually a few things I've actually learned that are different to what Jeremy presents that might be useful to some people. So as you also mentioned, find a project that interests you or a problem that you've got. I recently had a family of owls move into our backyard and was curious as to figure out what they were. I had some idea, but I thought, what better use case than creating an owl classifier? So that's what we're going to do, or that was a project that I picked. So we're using Colab, of course. We're using the T4 type to chain later on. So if it doesn't say T4 there, you're probably on CPU. You want to change that to T4. That's free, so that there's no cost to run the T4 GPU. You'll notice here that I've got an A100 V100. I've actually paid for credits. I've been doing some other testing as well on bigger models, and they come in really useful because they're much more powerful than the T4, much more memory. Worth spending a few bucks if you're serious about this, learning how to do deep learning. So first, of course, we install Fastai and also DuckDuckGo, right? So this is how we're going to search, similar to what Jeremy in his video shows. Then what we're going to do is straight afterwards install the import everything that we need. And then from there, the first thing we do is download and verify the required training data. So we create this search function, similar to what Jeremy has in his course, but the way he does it no longer works, no longer supported. So I have to do this method. So what we're doing is we're importing DDGS and we're running it as DDGS there in lowercase. We're searching for those images, so we're taking in the keywords, the owls that live in my area, in this instance, are here somewhere. There they are. They're the owls in my area. So I'm going to pass those into here, into this image search, and we're going to do a max of 200 images. Those will then get saved to a list, and there's a whole bunch of data that actually comes out. And I'll actually undo this so you can see what that looks like. We take those results and we just pull out the image URL so that we can download it later on. So I'm just going to hit go on that. That'll create the function. Then you can see here, this is to test it. So we're going to just do one image. We're going to use that download URL, which we imported up here. I've selected this to a barking owl. Again, that was one of the local ones. But to show you how this would work, maybe we choose the Australian masked owl. If I copy that, we can just change that here. Control V, Control V, Control V. And then if we run that cell, we should just get one image. And this is just a test, right? And here, there we go. We've got a masked owl. And this is this print function here. This is what we've got, Australian masked owl. It comes in a dictionary. We've got the image, and this is what we pull out, this actual image URL, a thumbnail and a bunch of other information that we really don't need. So this part here just sort of pulls out this image. So with that, we pull out the image link there. Right, next, I'll just re-comment that later so I don't forget. Next, what we want to do is you probably, as you've probably been playing around with Colab, every time you restart this or go away for an extended period, the session resets and you lose all your data. So what I found really useful is to set up Google with Drive, right? So Google Drive. So what happens here, if you use these few lines of code, it'll actually mount your Google Drive to the session so you can actually save data, and I'll show you what that looks like. So I'm just going to say, yeah, use my account. Continue, yep, great, it's all good. And there we go, that should finish in a sec, and you'll see it mount as Drive here. My Drive, and then I've got a bunch of stuff in here, right? So from there, what we need to do is create the path. So this is the path that I'm using to when we download all the data. You'll need to change this for when you do it, but the first part will be the same. It'll be content Drive and probably my Drive, and then you can put the data wherever you want. So I'm just going to set up that path variable. We're going to set up the owls in my area. So this would be a search for anything that you want. So whatever you want to classify. These will become the classifications for later as well. So not only are these the searches, these will be the folder names and the classifications for when we do run inference on the model. So now what we're actually going to do is actually download the images. Now, for the sake of this video, I'm going to show you what happened because I've already run this earlier. We'll go into Colab notebooks, our classifier, training data. As you can see, this path up here. I already have all the folders with all the images. So that takes quite a while. That uses that search images function. So when we go to download images, this search images function here leverages this function that we created earlier to actually download those images. This little function here, get image files, the path which we put in before, it'll just actually find the paths of all the files that are in there. So this is just a good little test to make sure, yep, hey, there's actually stuff in there. This is in Jeremy's training. If what we want to do is just remove all the broken images, right? Anyway, this is showing us that there were 20 images in there that, you know, linked to nowhere or broken for whatever reason. So this verify images is really very handy. Now, you know, Jeremy talks about this, so I'm just going to, you know, go through this really quickly. We create the data block. In this case, it's going to be an image data block, and the output is going to be a category. So in go images, outcome categories. Then we get the get image files. So that is this path up here. So we're going to get a list of all of those to be able to put them into the actual data block. The splitter, so this is about doing a 20% validation set, picking randomly, and then seeding 40 with a seed of 42. So if we run this again, it won't change the image order. Parent label, so this is about the folders. So if we have a look in here now, you'll see that in Colab notebooks, our classifier, training data, we've got those owls that we talked about before, and so those match up with these, right? So we've got the barn owl, southern bird, all those sorts of things, right? Then, so we've created our data block. Similar to the Fastai course, we then run this validate show batch on the object, so the data block object. And we can see we've got the labels and the owls sitting in there. So I'm going to go over what we can do to clean this up in a little bit, but as Jeremy says, you're better off just training a model first and then figuring out what's wrong. So we're going to just train this model. This is incredibly fast. This blew me away when I watched the video the first time. Like, I couldn't believe, because I've been fiddling around with large language models and the training was taking forever. But the quality that you can get with such small models is sort of blows my mind. So there we go. We've decided to fine tune this 3 times, so you can see 0 to 2. DLS is obviously that data block here that we created earlier. ResNet is the image classifier, the base model that we're fine tuning. And then the metrics error is, I think, outputs this. I haven't figured that bit out, but I assume it is. As you can see, the training loss is going down, as is the, validation loss and the training loss, which is good. The model is getting more accurate. So now it's time to test the model. That's what this bit of code does here. The first thing we need to do is upload an image. Now, I've got an image here that I'm going to upload. It's actually a picture of one of the owls in my backyard. So while we wait for that to upload, we can see here that we're taking the learn object and asking for a prediction based on that image. So this is a Python instruction language or something like that, which converts it into a format to enable the model to look at it. We're going to return the probability. This returns the index of the categories, but we're going to do this a different way. And then the probabilities, the tensor or the shape. Then the categories. As you can see here, it's got 6 items in it, so that's those 6 owls. So then what we do is, because we need floats and not tensors, we map each of the results or the predictions. We map them to the associated category, so we essentially stick them together with this zip function, and then we convert it to a dictionary so that we can print it out. Then we take the owl, as we said before, so we say this is whatever owl it's going to be, and then the probability. So we look up the probability dictionary, and then we provide the owl to figure out what the actual prediction was. So this is the actual owl that I took in my tree the other day. It's a picture, and this is what we're going to test this inference on. So there it is, and there's another one sitting in the background there. So I'm going to run this. It's going to go off, do the, and it come back, and this is the correct answer, right? And it's 95% sure it's correct, which is really, really incredible. You know, I found this so powerful and so motivating to continue this deep learning journey. So that's it. That's all I wanted to show you today. I'll link to this in the description below so that you can run this and edit it as you would. Any comments, if you're in the community, any comments would be great. I'm excited about this journey, and thank you for watching.